All right, in this segment, I'm going to talk about Big SQL security when we're running in the warehouse style or the default mode. So when you've installed Big SQL, this is the mode that is in by default. The way that you can double check that we're in the default mode is if you go into Embari and you go into Big SQL, look at the advanced config section in Embari. You see Big SQL env there. There'll be this enable impersonation and it should be set to false. That's the default. Now, one thing to note is that this is a read-only parameter. You can't actually change it here and cause any effect. It is actually configured in this path here, Big SQL home. That's a environment variable. You would need to be the Big SQL ID to see this. So you log into Big SQL service ID. That macro will be defined. Conf, Big SQL conf.xml. And if you haven't done anything, this will be set correctly. If you want to enable impersonation, see my deeper dive video on impersonation on how to change this. So let's get into how in this default mode we manage access to objects, authorization management. We know that there's this thing called the Hive metastore, which is where we get our definitions for the Hive tables. But there's also this thing called the Big SQL catalog, which is where we manage our advanced permissions capabilities inside Big SQL environment. So we have our users 1 and user 2, they're connecting in as non-privileged users. When they submit their queries, combination of things happen. We will check or get information about tables from the metastore if we don't already have it, and we will also look at the catalog to see if these users have permissions to read, write, or modify data in the objects that they're trying to get access to. And this is like the first gate. If it can get past that gate, then Big SQL will then issue those query snippets to the Big SQL workers and read that data. At this point, remember in the overview I talked about how if I'm running these Big SQL workers in the default mode, they're going to need to have read-write access to the files in HDFS because it's performing these operations on behalf of that connected user. If you don't know what I'm talking about, see the first video on the overview for security. Here I'll give you some more examples. You can pause the video if you like, where you can grant, select, grant, insert, update, delete, those kind of permissions. You can create roles for the database, and then you can assign users to roles and assign, select, insert, update, delete to the roles. So you can manage your authorizations by roles that they have in the organization. You can also grant permissions to groups as well. So that's another option. So all the stuff that you're used to in a regular data warehouse environment, those are available to you. And in fact, this stuff falls under ANSI standard SQL. So you can just bring those over and they'll run just fine. Now let me talk about the benefits of this default model. It is the most compatible with data warehouse security concepts. So if you're offloading data marts or data warehouses or bring workloads in from somewhere else that was a relational database system, this is going to be a very easy transition to bring that workload in. So it's going to be easy to understand, easy to manage. It's the most direct mapping, right? So all your existing grant and revoke statements can just be brought over, and all your role-based access control can be brought over. And if you have row and column level security that you want to bring over, that will work too. So we've got that capability. So the main benefit of this, I think, is that we have the opportunity to close all backdoors because there's no direct access to HDFS unless I've granted it. So as we create tables through Big SQL, those files and directories in HDFS are owned by Big SQL, and the only way to that data will be through a Big SQL connection. So we've closed those backdoors. Let me also comment on the common ways that we will move data around in Big SQL and the impact on permissions. Now, I'll start with the load command. The load command can read any data source that the user can read. When we load the data, they will end up populating tables where the files are accessible by Big SQL, and so that is preserved. If I perform an insert statement, regardless of what user I am, those data values that are created are written to new files in HDFS, and those files will be owned by Big SQL. And I have the opportunity as well to put data in HDFS manually, because maybe I have some external data ingest framework, and those files are owned by some other user. And that's okay. All I have to make sure is that we allow Big SQL Service ID to have read-write permission on those files. A little bit more information here about the load utility. So a very common way to bring data into Hadoop is through Scoop and maybe a combination of Scoop and other tools, and that's fine. But there are some benefits to our load utility in that you can shortcut a few steps. We're loading into a target table definition that Big SQL is intimately aware of. So those are some of the benefits. So when we do the load utility in Big SQL, it actually has some tooling capabilities wrapped around Scoop, and we may read from the local file system of the data node or an edge node. It could be from HDFS into another set of paths where the table are residing. It could be an SFTP source, or maybe it's object store, right? So this load Hadoop command that Big SQL ships in the package will then be able to load either HBase tables or Hive tables, and that Hive table could already be predefined with partitioning, with ORC and all that kind of stuff. So that's kind of a nice and convenient way to bring data in. Now, the data that's coming into the load utility can be owned by any user and any process, as long as the user who is executing that command can read the data. But once the data is passed through the load utility, it'll be written to the table, and that user will need to have access to the table, but the files that are ultimately written are still owned and accessible by the Big SQL Service ID. Now, I mentioned before that you could also populate Big SQL manually. Maybe you're just putting stuff in HDFS or using some external data ingest framework. Maybe it's a Kafka ingest framework. So here's an example of how to do this, okay? You have some source data and you land it into HDFS as a set of files. Here I've got file 1, file 2, file 3 that make up a table called my table. And let's say that this owner is some user ID 036538. Now, I want to create a Hive table over this data set without moving it, right? I just want to create an external table. So what I can do is I can say, create schema, app1, location, and give it a path. And this path will be the path where I've loaded my data, the root path. From there, I can say, create external table, my table, over that location. And you notice I've got an extra layer in the directory here. It's app1.db/mytable. Now there's one more thing we have to do. Remember, we're running in warehouse mode where the processes are running on behalf of the end user, but they're running still as the Big SQL Service ID. So two choices. Either, I'm going to talk about method 2 first. Either you change the ownership of those files to be Big SQL, which is actually kind of unlikely because maybe it's a different team bringing the data in and a different team managing Big SQL, but that's one option. The second option is to take advantage of access control lists that are already in HDFS. So you could say HDFS DFS set FACL -R, that means recursive, -M means modify. The user Big SQL, that's the user I want to give access to. And now the permission will be read, write, execute. That's what Big SQL requires. And I'm going to set it to that path, data app1.db. And then I'm going to follow on with another set FACL command, modify, and we're going to set the default for user Big SQL, read, write, execute permission also on that directory. And what this does is that for all future files that land in the directory, they will also inherit this same access control authorization for Big SQL. So as we ingest new data sets in the future, they will inherit this permission. So with this approach, with setFACL, the file ownership remains owned by the service ID S036538, but Big SQL will also have this specialized access to the files. Next, let me talk about schema creation. So in Hive and Big SQL, Hive and schema mean the same thing. It's just a logical place or a namespace to group objects together. Helps us organize our objects. Now, when you say in Big SQL, create schema, my schema, that becomes a metastore operation. And in the metastore, we will register that the schema belongs by default in apps hive warehouse my schema.db. That's just a path in HDFS. Now, the reason why this is in Hive warehouse is because this is, the default path or for our Hive managed tables. But what if I want a different path? What if my data is an external table and the files are in a different path, and I want my schema in a different place? Maybe it's a user home directory. I can also say create schema my schema and give it a specific location. In this case, I've chosen an HDFS home directory for Paul, that's me, and this thing called my schema.db. So what happens then is this becomes again a metastore operation, and it stores this as the path that I wanted, again in the metastore. So both Hive and Big SQL will understand that schema to be on the same path. Now remember that if you do this with this path, you need to make sure that the Big SQL ID can have access, read, write, execute access to this myschema.db path. And I've shown you in the previous slide how you can use the access control list, set facl commands to enable that. When you first log into Big SQL, you may not issue a create schema command. And this is one significant difference between Hive and Big SQL. In Hive, when you connect and just say create table whatever, that whatever table will be placed in a default schema. Okay. However, in Big SQL, we don't have that. Our default schema is actually mapped to your user ID that you connect with. So in this example, if I'm connected as user Paul, and I say create Hadoop table my table, there's no schema explicitly specified here. And so what we call this is implied schema is Paul. So we ask the metastore, does that schema already exist in Hive? If not, we're going to create this directory, apps hive warehouse paul.db, and that directory is created. If I have other objects or a default schema assigned to me, what will happen is the data will be accessed from the HDFS path associated with the schema in Hive. So maybe that's this path that was created from a previous object creation or an explicit schema creation, or maybe some other schema that I created already manually. So that's it for the default security model. Basically, it's grant and revoke statements. There's an implied schema that matches your user ID, and whatever schema you decide to create, whatever paths of data sets you want to create, make sure that the Big SQL ID is able to read, write, and access those directories. Hey, I want to thank you for watching these series of seminars. This was made possible with the support of the IBM Client Center, the Lab Briefing Center here in the IBM Toronto Lab. The Toronto Lab is where the core architecture team, most of the developers for Big SQL are located. And if you want to hear more about Big SQL, do deeper dives, hear from our architects, do strategic planning with us, come in, work with the IBM rep to request a lab briefing, and we look forward to seeing you here. Also, don't forget to subscribe. Thanks.